What if the secret to humanity's survival among the stars isn't found in rocket fuel or advanced spacecraft, but in a technology we're already using here on Earth? A future where we live, build, and sustain ourselves on distant planets isn't just a dream. It's something 3D printing could make possible. Think about it. Instead of hauling massive supplies across the void of space, we could create what we need right there on the surface of Mars or the Moon. This isn't science fiction. It's the next step in space exploration. From crafting habitats that shield us from harsh alien environments to manufacturing tools and even growing food, 3D printing could be the foundation of self-sufficient space colonies. Today, we're going to uncover how this groundbreaking technology is set to redefine life beyond Earth, and why it could be the key to humanity's survival in the cosmos. Let's dive in. The story of 3D printing is a fascinating journey of innovation that began decades ago as a groundbreaking tool for prototyping. What started as a way to create small-scale models quickly has transformed into a technology that's reshaping entire industries. From aerospace to healthcare, 3D printing has revolutionized manufacturing by allowing for intricate designs, rapid production, and the ability to create objects layer by layer with precision. But the most exciting chapter of this story isn't happening on Earth. It's unfolding in the vast expanse of space. NASA and private space companies like SpaceX have been at the forefront of exploring how 3D printing can thrive in environments where traditional manufacturing simply isn't possible. Imagine being able to print a replacement part for a spacecraft while it's in orbit, or constructing entire habitats on the Moon or Mars using materials found on site. These aren't just dreams, they're experiments already underway. For example, NASA In Situ Resource Utilization Program is investigating how to use lunar regolith, the dust covering the Moon's surface, as a raw material for 3D printing. But space presents unique challenges. In microgravity, materials behave differently, and traditional manufacturing methods don't apply. That's why researchers are developing specialized 3D printers designed to operate in zero-gravity environments. These printers aren't just modified versions of Earth-based machines, they're entirely reimagined tools built to handle the complexities of space, and the implications are enormous. With 3D printing, future space colonies could reduce their reliance on Earth for supplies, making them more self-sufficient and sustainable. What's remarkable is how quickly this technology is evolving. Just a few years ago, 3D printing in space was a far-fetched idea. Today, it's a critical component of plans for long-term space exploration. As we continue to push the boundaries of what's possible, 3D printing stands out as one of the key technologies that will enable us to not just visit space, but to truly live there. Building a self-sufficient colony in space is like trying to assemble a puzzle with missing pieces. The biggest challenge, transporting materials from Earth, is not just expensive, it's nearly impossible on the scale needed for a thriving colony. Imagine trying to ship every single brick, tool, and spare part across millions of miles of space. The costs alone would be astronomical, and the process would be incredibly inefficient. That's where 3D printing steps in as a game changer. Instead of relying on shipments from Earth, colonists could harness local resources like lunar or Martian soil to create what they need right on site. Think of it as turning the very ground beneath their feet into a factory for survival and growth. One of the most exciting aspects of 3D printing in space is its versatility. It's not just about building shelters, though that's critical. It's about creating an entire ecosystem of tools and machinery tailored to the colony's unique needs. Need a replacement part for a broken rover? Print it. Require a custom tool for a scientific experiment? Print that too. This technology transforms the way we think about resource management in space, shifting from reliance on Earth to self-sufficiency. But let's not overlook the bigger picture. Space colonization isn't just about survival, it's about thriving. 3D printing enables colonists to innovate and adapt, turning challenges into opportunities. For example, structures built with 3D printers can be designed to withstand the harsh conditions of space, from extreme temperatures to radiation exposure. This level of customization ensures that colonies aren't just temporary outposts but sustainable habitats for long-term exploration and discovery. So, why is 3D printing so crucial for space colonies? It's about more than just convenience, it's about redefining what's possible. By leveraging this technology, we can overcome the logistical hurdles of space colonization and pave the way for a future where humanity thrives beyond Earth. Picture this, a colony on the Moon or Mars, where the first structures aren't shipped from Earth but built right there using the materials beneath their feet. One of the most immediate and essential applications of 3D printing in space is the creation of habitats. Shelter isn't just a luxury, it's a survival necessity. In the vacuum of space, extreme temperatures and constant exposure to radiation, traditional construction methods just won't cut it. That's where 3D printing steps in, offering a game-changing solution. Instead of hauling heavy building materials across millions of miles, astronauts could use local resources like regolith, the loose, rocky material found on the Moon and Mars, to print habitats directly on site. These 3D printed structures aren't just cost-effective. They're designed to be incredibly durable and radiation-resistant, providing safe and secure living spaces for colonists. NASA has already been exploring this possibility through initiatives like the 3D Printed Habitat Challenge, which encourages innovators to design and prototype habitats that could one day house humans on other worlds. What's truly fascinating is how these habitats are engineered to withstand the harsh realities of space. Think about it: no atmosphere, intense cosmic radiation, and temperatures that swing from scorching heat to bone-chilling cold. 3D printed habitats are being designed with these challenges in mind, using layered construction techniques that create thick, protective walls. And the potential doesn't stop there. These habitats could be modular, meaning they can start small and expand as the colony grows. Imagine a base that starts as a single living pod but evolves into a sprawling complex, all thanks to the flexibility of 3D printing technology. This isn't just science fiction, it's a vision of the future that's already taking shape. By leveraging local materials and cutting-edge printing techniques, 3D printed habitats could become the foundation of self-sufficient space colonies, turning barren landscapes into thriving human settlements. When you're millions of miles from Earth, a missing wrench or a broken piece of equipment isn't just inconvenient, it could be life-threatening. This is where 3D printing steps in, transforming the way we think about manufacturing in space. Imagine needing a specific tool for a repair job. Instead of waiting months for a resupply mission, colonists could design and print that tool in hours, tailored exactly to their needs. 3D printers can create everything from simple wrenches to complex medical devices, turning what was once a logistical nightmare into a manageable task. The beauty of this technology lies in its adaptability. Colonists won't need to carry an endless inventory of tools. Instead, they'll have a compact 3D printer capable of producing whatever is required on the spot. And the materials, they don't even need to come from Earth. Recycled plastics, metals extracted from asteroids, or even lunar regolith could be used as raw materials, making the process sustainable and resource efficient. This isn't just theoretical, it's already happening. On the International Space Station, astronauts have used 3D printed tools to perform repairs and experiments. For example, in 2015, NASA successfully printed a ratchet wrench on the ISS, demonstrating the practicality of this technology in zero gravity. These advancements aren't just about convenience, they're about survival. In the harsh environment of space, the ability to manufacture tools on demand could mean the difference between success and disaster. So, what does this mean for future space colonies? It's a game changer. 3D printing isn't just a tool, it's a lifeline, ensuring that colonists can adapt, innovate, and thrive in the most challenging conditions imaginable. When we think about sustaining life in space, one of the most pressing challenges is food production. Feeding a colony on Mars or the Moon isn't just about packing freeze-dried meals. It's about creating a self-sufficient system that can thrive in the harshest environments. Here's where 3D printing steps in as a game changer. Imagine a colony where instead of relying on Earth for shipments of food, astronauts could print nutrient-rich meals on demand. This isn't science fiction, it's already being explored using sustainable sources like algae, fungi, and even plant-based proteins. These ingredients can be transformed into edible, nutrient-dense foods tailored to the unique dietary needs of space travelers. But it doesn't stop at food. 3D printing also opens the door to producing biodegradable materials that are essential for a sustainable space economy. Think about it, in a closed environment like a space colony, waste management becomes a critical issue. By printing materials that can break down naturally, we can create a circular system where waste is minimized and resources are reused. This approach not only reduces the logistical burden of shipping supplies from Earth, but also aligns with the goal of creating a self-sufficient, eco-friendly colony. One of the most exciting innovations in this field is the development of 3D printed plant-based meats. Projects on Earth are already experimenting with printing steaks and burgers from plant proteins, and these technologies could be adapted for extraterrestrial use. Picture a future where colonists enjoy a freshly printed, protein-packed meal made from ingredients grown on site. It's a blend of cutting-edge technology and sustainability that could redefine how we think about food in space. This capability isn't just about convenience, it's about survival. By integrating 3D printing into food and material production, space colonies can achieve a level of independence that makes long-term habitation not just possible but practical. It's a step toward turning the dream of living among the stars into a sustainable reality. In the vast emptiness of space, every bolt, every panel, and every spare part becomes a lifeline. When you're millions of miles from Earth, there's no hardware store to visit, no quick delivery service to save the day. This is where 3D printing steps in as a game changer, offering a way to repair, recycle, and reinvent the tools and structures that keep space colonies alive. Imagine a critical piece of equipment on a spacecraft failing mid-mission. Instead of scrambling for a replacement, colonists could simply print a new component on demand using materials already on board. This isn't just about convenience, it's about survival. Beyond repairs, 3D printing opens up incredible possibilities for recycling. Space missions generate waste, but in the hands of a 3D printer, that waste can be transformed into something useful. Old parts, discarded packaging, or even broken tools can be melted down and reshaped into new items, breathing new life into materials that would otherwise be lost. This closed-loop system ensures that every gram of material is used to its fullest potential, reducing the need to carry extra supplies from Earth and making colonies more self-sufficient. Think about the habitats themselves. Over time, wear and tear from harsh conditions like radiation, temperature extremes, and micrometeoroid impacts could compromise structures. With 3D printing, damaged sections of a habitat could be repaired or even upgraded on the spot, ensuring the safety and comfort of its inhabitants. This adaptability is crucial for long-term missions, where the ability to fix and improve infrastructure could mean the difference between success and failure. The beauty of this technology lies in its versatility. Whether it's a broken tool, a cracked habitat wall, or a spare part for a rover, 3D printing provides a solution that's both practical and sustainable. It's not just about surviving in space, it's about thriving, building a future where space colonies can sustain themselves independently, far from Earth's reach. And as we look ahead, this capability could become the cornerstone of humanity's expansion into the cosmos. When it comes to survival in space, two resources are non-negotiable: energy and water. The challenge, of course, is how to access, manage, and sustain these vital elements in an environment where they're not naturally abundant. This is where 3D printing steps in as a game changer, offering innovative ways to build the infrastructure needed to secure these resources for long-term space colonies. Take energy, for instance. Solar power is one of the most reliable options in space, but traditional solar panel manufacturing is complex, costly, and not practical for off-world production. Enter 3D printing. This technology allows us to create lightweight, durable solar panels directly on site using materials that can be sourced from the moon or asteroids. Think about it. Instead of transporting bulky panels from Earth, we could print them in space, tailored to the specific conditions of the colony. This not only reduces costs but also ensures a steady, renewable energy supply. Water is another critical piece of the puzzle. In space, every drop counts, and recycling water efficiently is essential. 3D printing can help build advanced filtration and purification systems that are both compact and highly effective. These systems could be designed to extract water from lunar ice or even from the air inside habitats, turning what's scarce into something sustainable. Imagine a network of 3D printed pipes, tanks, and filters working together to ensure a colony always has access to clean, safe water. What's truly remarkable is how these systems can be integrated seamlessly. For example, solar-powered energy grids could power water purification units, creating a self-sustaining loop that minimizes waste and maximizes efficiency. This kind of synergy is exactly what future space colonies will need to thrive. By leveraging 3D printing for energy and water infrastructure, we're not just solving immediate survival challenges, we're laying the groundwork for a resilient, self-sufficient future beyond Earth. It's a testament to how this technology can transform the way we think about living in space. When it comes to keeping space colonists healthy, medical care isn't just important, it's a matter of survival. In the isolated environment of a space colony, traditional supply chains for medical equipment simply won't be an option. That's where three-dimensional printing steps in, offering a groundbreaking solution. Imagine a scenario where a colonist suffers an injury or requires surgery. With three-dimensional printing, essential medical supplies like surgical instruments, bandages, or even casting materials can be created on demand right there in the colony. But it doesn't stop there. One of the most exciting applications is in the field of prosthetics. Three-dimensional printing allows for the creation of custom-fitted devices tailored to the individual's exact needs, all without the need for bulky, pre-manufactured parts. This technology isn't just about convenience, it's about ensuring colonists can maintain their health and mobility in an environment where every resource counts. Now, let's take this a step further with bioprinting, a cutting-edge advancement that's revolutionizing medicine both on Earth and potentially in space. Bioprinting uses three-dimensional printing techniques to create living tissues, layer by layer, from bioinks made of living cells. In space, this could mean the ability to produce skin grafts for burns, repair damaged tissues, or even print small organ structures for transplants. While we're not yet at the stage of printing fully functional human organs, the progress in this field is staggering. For space colonists, bioprinting could mean the difference between life and death in emergencies where resupply from Earth isn't feasible. It's not just a tool, it's a lifeline, ensuring that colonists have access to advanced medical care, no matter how far from home they are. With every innovation, three-dimensional printing is proving itself to be a cornerstone of self-sufficient space colonies, turning what once seemed like science fiction into a tangible, life-saving reality. When it comes to exploring the vast, uncharted terrain of other planets, mobility is everything. Think about it. How can we uncover valuable resources, map new territories, or even build infrastructure if we can't move efficiently? That's where 3D printing steps in, offering groundbreaking solutions for transportation systems in space colonies. Unlike Earth, other planets present extreme conditions like Mars' rocky, uneven surfaces or the Moon's fine, abrasive dust. Traditional vehicles simply aren't designed to handle these challenges, but with 3D printing, we can manufacture rovers, drones, and even spacecraft specifically engineered to thrive in these environments. Imagine a rover with lightweight, durable parts printed on site, customized to navigate rough terrain or withstand harsh weather. Or consider drones equipped with specialized sensors, printed to assist in mapping or delivering supplies across vast distances. The possibilities extend beyond the ground too. 3D printing could revolutionize how we build spacecraft, creating components that are lighter, stronger, and more efficient than anything made with traditional methods. This isn't just about convenience, it's about opening up entirely new possibilities for interplanetary exploration and expansion. With 3D printing, the future of space travel isn't just faster, it's smarter, more adaptable, and ready for the unknown. Now, let's shift our focus to something that's absolutely critical for the survival and success of any space colony: communication. Staying connected isn't just a convenience out there, it's a lifeline. Whether it's coordinating with Earth, relaying critical data, or keeping colonies in touch with one another, a reliable communication network is non-negotiable. And this is where 3D printing steps in with game-changing potential. Picture this. Instead of launching pre-built antennas, satellites, or relay stations from Earth, which is both expensive and logistically challenging, we could fabricate these components on site using 3D printing technology. Imagine a colony on Mars or the Moon, equipped with printers that can produce lightweight, durable antennas designed to withstand the harsh conditions of space. These devices could be customized to fit the specific needs of the colony, whether it's for high-frequency data transmission or long-distance signaling. But it's not just about creating the hardware. 3D printing also allows for rapid prototyping and iteration. If a communication device fails or needs an upgrade, new parts can be printed quickly, minimizing downtime. This kind of flexibility is crucial in environments where every second counts and resupply missions are few and far between. Plus, with advances in materials like conductive polymers and specialized metals, 3D printed communication devices can achieve performance levels that rival their Earth-made counterparts. And let's not forget the bigger picture. As more colonies are established, they'll need to communicate with each other, forming an interplanetary network. 3D printed satellites could act as relays, creating a web of connectivity across vast distances. This wouldn't just support scientific collaboration, it would also foster a sense of community among the pioneers of space exploration. So, while 3D printing might seem like a tool for building physical structures, its role in constructing communication networks could be just as transformative. It's about ensuring that, no matter how far we venture into the cosmos, we're never truly alone. Life in a space colony isn't just about survival, it's about thriving. Imagine being millions of miles from Earth, surrounded by the vast emptiness of space. To truly flourish, colonists will need more than just the essentials. This is where 3D printing steps in, offering a way to create educational tools, games, and recreational equipment that support mental and emotional well-being. Think about it, a colony isn't just a place to exist, it's a community, a home. And a home isn't complete without opportunities to learn, play, and connect. 3D printing can produce a wide range of items to enrich daily life. For education, imagine 3D printed models of the solar system, anatomical diagrams for medical training, or even custom-designed puzzles to challenge young minds. These tools make learning interactive and engaging, fostering curiosity and growth. For recreation, astronauts could print everything from board games and musical instruments to exercise equipment tailored to the unique challenges of microgravity. Picture a group of colonists gathered around a 3D printed chess set, or playing a tune on a printed flute, small moments that bring joy and normalcy to an extraordinary environment. But it's not just about fun. These creations play a critical role in maintaining mental health. Isolation and confinement in space can take a toll on anyone, and having access to activities that stimulate the mind and body can make all the difference. A 3D printed guitar might spark creativity, while a set of workout weights could help relieve stress. Even crafting tools for hobbies like knitting or painting can provide a sense of purpose and relaxation. The beauty of 3D printing lies in its adaptability. As colonists' needs evolve, so can the objects they create. If someone misses the thrill of basketball, why not print a smaller, zero-gravity version of the game? If a child wants to explore engineering, a 3D printed robotics kit could ignite their passion. The possibilities are as vast as space itself. By enhancing quality of life, these 3D printed items do more than entertain. They help build a resilient, cohesive community. They remind us that even in the most challenging environments, humanity's creativity and spirit can flourish. After all, thriving isn't just about having what we need, it's about having what makes life meaningful. Space colonies are destined to become more than just habitats. They'll be epicenters of groundbreaking science, and here's where 3D printing plays a pivotal role. Imagine the challenges of conducting research millions of miles from Earth. Transporting delicate, specialized lab equipment across such vast distances is not only impractical but also incredibly expensive. That's where 3D printing steps in, offering a solution that's as innovative as the research it supports. With 3D printers, scientists in space colonies can fabricate everything from microscopes to spectrometers on demand. Need a custom-designed device for a unique experiment? No problem. A 3D printer can turn digital blueprints into physical tools in hours, bypassing the need for costly and time-consuming resupply missions. This flexibility is a game-changer, allowing researchers to adapt quickly to new discoveries or unexpected challenges. But it's not just about convenience. 3D printing also opens the door to entirely new types of scientific exploration. For instance, materials that behave differently in microgravity can be tested and utilized in ways that aren't possible on Earth. Think of custom-designed sensors or lightweight, durable components for space telescopes, tools that could help us peer deeper into the cosmos than ever before. And let's not forget the collaborative potential. Space colonies could become hubs where scientists from around the world, or even other colonies, share designs and innovations. A breakthrough in one lab could be replicated in another within days, accelerating the pace of discovery exponentially. Ultimately, 3D printing isn't just supporting scientific research, it's transforming how we conduct it. By enabling self-sufficiency and fostering creativity, this technology is helping to unlock the mysteries of the universe, one printed tool at a time. One of the most fascinating aspects of 3D printing in space is the question of what materials we can actually use. Unlike on Earth, where we have easy access to metals, plastics, and other resources, space colonies will need to rely on what's already available in their environment. And this is where things get really interesting. Picture this: instead of shipping materials from Earth at astronomical costs, future space settlers could use materials like lunar regolith, the fine layer of dust and rock covering the moon's surface. Scientists have already demonstrated that lunar regolith can be processed and used in 3D printers to create everything from bricks to tools, making it a game changer for building sustainable habitats on the moon. But the moon isn't the only option. On Mars, the planet's reddish soil, rich in iron oxide, could also be a treasure trove of raw material. Researchers are experimenting with ways to extract metals and other compounds from Martian soil, which could then be used for 3D printing. It's not just about convenience, it's about survival. Being able to use local materials means reducing reliance on Earth and creating self-sufficient colonies. And then there's the potential of asteroids. These space rocks are packed with valuable metals like nickel, cobalt, and even platinum. While mining asteroids is still in its early stages, the idea of using asteroid metals for 3D printing is incredibly promising. Imagine a future where asteroids are harvested, processed, and transformed into construction materials or spare parts for spacecraft, all while floating in the vastness of space. But it's not just about finding new materials, it's also about making the most of what we already have. Recycling will play a crucial role in space colonies. Every piece of waste, from packaging to old equipment, could be repurposed into something useful. NASA has already explored techniques to recycle plastic waste into filament for 3D printers, turning trash into tools. It's a perfect example of how innovation can turn challenges into opportunities, ensuring that space colonies remain efficient and sustainable. So, whether it's lunar dust, Martian soil, asteroid metals, or even recycled waste, the possibilities for 3D printing materials in space are vast and exciting. The key lies in creativity, adaptability, and the willingness to think outside the box, or, in this case, outside our planet. One of the most fascinating yet complex aspects of 3D printing in space is how microgravity complicates the process. Here on Earth, gravity plays a crucial role in ensuring materials behave predictably. Molten plastic or metal naturally adheres to surfaces and cools into solid shapes. But in the weightlessness of space, things work differently. Without gravity, materials don't layer or settle as intended, which can lead to defects in the printed object. Imagine trying to build a structure where every component floats away the moment it's released. It's a challenge that requires entirely new approaches. Material adhesion is a major hurdle. In microgravity, even the slightest movement can disrupt the placement of layers, causing misalignment or weak spots. This isn't just about creating objects that look good, it's about ensuring they're strong enough to withstand the harsh conditions of space. Structural integrity becomes a critical concern, especially for components that must endure extreme temperatures, radiation, or mechanical stress. But here's where innovation steps in. Scientists and engineers are developing specialized techniques to adapt 3D printing for microgravity. For example, some are experimenting with electromagnetic or adhesive surfaces to keep materials in place during the printing process. Others are redesigning printers to operate in multiple dimensions, allowing for greater precision and control. These advancements aren't just theoretical, they're being tested on the International Space Station, where every successful print brings us closer to mastering this technology for future missions. The challenges of 3D printing in microgravity are undeniable, but they're also driving some of the most exciting breakthroughs in space technology. By solving these problems, we're not just improving the way we print in space, we're paving the way for self-sufficient colonies that can thrive far beyond Earth. When we think about 3D printing in space, it's not just a futuristic concept, it's happening right now, and the results are nothing short of groundbreaking. Take the International Space Station, for example, where Made in Space's 3D printer has been operating since 2014. This isn't just any printer. It's a tool designed to function in microgravity, allowing astronauts to manufacture tools and spare parts on demand. Imagine needing a wrench or a replacement component and simply printing it within hours, rather than waiting for a resupply mission from Earth. This level of self-sufficiency is a game-changer for long-term missions, reducing reliance on Earth and enabling astronauts to adapt to unforeseen challenges in real time. Beyond the ISS, the European Space Agency is pushing the boundaries even further with its ambitions for lunar construction. Using 3D printing technology, ESA envisions building habitats on the Moon using local materials like lunar regolith, essentially turning moon dust into solid structures. This approach not only cuts down on the cost and logistical challenges of transporting building materials from Earth, but also paves the way for sustainable, long-term lunar bases. Think of it as the ultimate recycling project, where the Moon's natural resources are harnessed to create shelter, infrastructure, and even tools for future explorers. These projects are more than just experiments. They're proof of concept that 3D printing can play a critical role in humanity's journey beyond Earth. From manufacturing essentials in orbit to constructing entire habitats on other worlds, the technology is being put to the test in ways that bring us closer to the dream of self-sufficient space colonies. The progress being made today lays the foundation for a future where we're not just visitors in space but permanent residents, thriving in environments we've built with our own ingenuity and tools. As we look ahead, the role of 3D printing in space is poised to evolve in ways that once seemed like science fiction. The next frontier isn't just about printing tools or spare parts. It's about creating entire systems and habitats that could sustain life beyond Earth. One of the most exciting developments is the integration of artificial intelligence into 3D printers. Imagine a machine that can adapt to unpredictable conditions in space, like microgravity or extreme temperatures, and make real-time adjustments to ensure flawless production. These AI-driven printers could become autonomous architects, designing and constructing structures with precision and efficiency. But it's not just about smarter machines, it's also about the materials we use. Researchers are exploring advanced composites and even self-healing polymers that can withstand the harsh environment of space. These materials could revolutionize how we build everything from spacecraft components to radiation shielding, making long-term space habitation more feasible. And then there's the big picture, interstellar travel. 3D printing could play a critical role in enabling humanity to venture beyond our solar system. By printing fuel tanks, propulsion systems, or even entire spacecraft in orbit, we could reduce the cost and complexity of deep space missions. Imagine a future where astronauts on their way to distant stars can print replacement parts or even food, eliminating the need to carry everything from Earth. The potential here is staggering, and it's not just about technology, it's about rethinking how we approach exploration and survival in space. As these innovations continue to develop, they could fundamentally change our relationship with the cosmos, turning the impossible into the inevitable. What's clear is that 3D printing will be at the heart of this transformation, shaping the future of space travel and colonization in ways we're only beginning to imagine. Beyond its practicality, 3D printing introduces a host of economic and environmental advantages that could revolutionize space exploration. One of the most significant benefits lies in cost reduction. Traditional space missions often require transporting massive amounts of equipment and materials from Earth, a process that is not only expensive but also limited by payload capacity. With 3D printing, we can shift from shipping pre-made components to sending compact raw materials or even utilizing resources found on site, like lunar regolith or Martian soil. This approach drastically cuts down on transportation costs, making space missions more financially viable in the long term. Sustainability is another critical advantage. Space missions, as they're currently conducted, generate substantial waste, discarded packaging, unused materials, and outdated equipment. 3D printing offers a solution by enabling precise, on-demand production. Need a spare part? Print it. Need a new tool? Print it. This ability to create exactly what's needed when it's needed minimizes excess and reduces the overall environmental footprint of space exploration. But the benefits don't stop there. By leveraging local materials, 3D printing reduces reliance on Earth's resources, which are already under strain. Imagine a future where lunar bases or Martian colonies use the very ground beneath their feet to build habitats, tools, and infrastructure. Not only does this make missions more self-sufficient, but it also paves the way for a more sustainable approach to exploring and inhabiting other worlds. What's truly exciting is how these economic and environmental benefits complement each other. Lower costs make space exploration more accessible, while sustainable practices ensure that these endeavors don't come at the expense of our planet. Together, they form a powerful case for why 3D printing isn't just a tool for innovation. It's a cornerstone for the future of space colonization. As we marvel at the possibilities of 3D printing in space, it's crucial to pause and consider the ethical implications that come with this transformative technology. After all, every leap forward brings new challenges, and space exploration is no exception. Who gets to control the resources extracted from asteroids or lunar surfaces? How do we prevent a scenario where some colonies thrive while others struggle to survive? These aren't just hypothetical questions, they're pressing concerns that could shape the future of humanity beyond Earth. One of the most significant ethical dilemmas revolves around resource ownership. Imagine a future where a handful of nations or corporations dominate access to raw materials in space, using 3D printers to build thriving colonies while others are left behind. This could create a new kind of inequality, one that extends beyond our planet. To avoid this, international agreements will be essential to ensure that space resources are shared fairly and that all colonies, regardless of their origin, have the opportunity to flourish. But fairness isn't just about access to materials, it's also about the technology itself. Advanced 3D printers could become a lifeline for struggling colonies, enabling them to produce everything from tools to shelter. Yet, if these machines are too expensive or complex for smaller colonies to operate, it could widen the gap between the haves and the have-nots. To address this, we'll need policies that prioritize the equitable distribution of 3D printing technology, ensuring that no colony is left without the means to sustain itself. Beyond ownership and access, there's also the question of responsibility. Who ensures that 3D printed resources are used ethically and sustainably? In the vastness of space, oversight is challenging, but it's not impossible. Establishing transparent governance structures and ethical guidelines will be key to preventing misuse and ensuring that 3D printing serves as a tool for collective progress rather than conflict. The vision of self-sufficient space colonies isn't just about technological innovation. It's about building a future that's fair and inclusive for all. The future of 3D printing in space isn't just about groundbreaking technology, it's about teamwork. Think about it. No single entity, whether a government or a private company, can tackle the challenges of space colonization alone. It's going to take a global effort with governments, private companies, and international organizations working hand in hand. These partnerships are already proving to be the backbone of innovation in this field. For example, NASA has teamed up with private aerospace companies to develop 3D printed habitats and tools for use on the Moon and Mars. These collaborations bring together the resources, expertise, and creativity needed to push the boundaries of what's possible. But it's not just about pooling resources, it's about leveraging unique strengths. Governments often provide the long-term vision and funding for ambitious space projects, while private companies bring agility, cutting-edge technology, and a drive for efficiency. Take SpaceX, for instance. Their work in reusable rockets has drastically lowered the cost of getting materials into space, making 3D printing projects more feasible. Meanwhile, international organizations like the European Space Agency are fostering cross-border cooperation, ensuring that space exploration remains a shared human endeavor rather than a competition. These partnerships are also shaping the policies and frameworks that will guide space colonization. Without clear regulations and agreements, the use of 3D printing in space could become chaotic or even dangerous. Governments and private entities are working together to establish guidelines for everything from resource extraction on the moon to the ethical use of space-based manufacturing. It's a complex process, but it's essential for creating a sustainable and equitable future in space. What's exciting is that these collaborations are already yielding results. From 3D printed components on the International Space Station to early prototypes of lunar habitats, the progress is tangible. And as these partnerships continue to grow, they'll unlock new possibilities that we can barely imagine today. The success of 3D printing in space isn't just a technological achievement, it's a testament to what humanity can accomplish when we work together toward a common goal. The dream of self-sufficient space colonies isn't just a sci-fi fantasy, it's a rapidly approaching reality, and you can play a role in shaping it. Whether you're passionate about space exploration or fascinated by the potential of 3D printing, there are tangible ways to contribute to this groundbreaking movement. Let's explore how you can get involved and make an impact. One of the most powerful steps you can take is to focus on education. Start by diving into subjects like engineering, material science, or robotics fields that are foundational to 3D printing and space technology. Many universities and online platforms offer courses specifically tailored to these areas, making it easier than ever to build expertise. Even if you're not aiming for a technical career, understanding the basics can help you advocate for and support these initiatives. Another way to contribute is by backing organizations and projects dedicated to space exploration and sustainable technology. From crowdfunding platforms to established space agencies, there are countless opportunities to support research and development. Your support, whether financial or through spreading awareness, can help accelerate progress towards self-sufficient colonies. If you're looking for a more hands-on approach, consider exploring careers in 3D printing or space industries. From designing and manufacturing space-grade components to developing new materials for extraterrestrial construction, the possibilities are vast. Even if you're not an engineer, roles in project management, logistics, or communications are crucial to the success of these missions. And don't underestimate the power of community. Joining forums, attending conferences, or connecting with like-minded individuals can spark ideas and collaborations that push the boundaries of what's possible. The journey to space colonization is a collective effort, and your unique skills and perspective are valuable. The future of self-sufficient space colonies is being built today, and it's a future you can help shape. Whether through education, advocacy, or direct involvement, every step you take brings us closer to making this vision a reality. The cosmos may seem vast, but your contribution, big or small, can leave a lasting impact. As we've explored throughout this video, three-dimensional printing stands as a game-changing technology for the future of space colonization. Its ability to create habitats, tools, food, and even medical supplies directly on site addresses some of the most daunting challenges of living beyond Earth. Imagine landing on Mars or another distant world, and instead of relying on shipments from home, you could manufacture everything you need with raw materials found on the planet itself. This isn't just science fiction, it's a tangible future made possible by innovations in three-dimensional printing. The implications are enormous, offering a pathway to self-sufficiency that could transform how we approach space exploration. The journey to the stars is no longer about what we can bring with us, but what we can create once we're there. Thank you for being part of this exploration. If you found this video insightful, give it a like, subscribe for more futuristic tech content, and let us know your thoughts in the comments. Together, we're building a future where humanity thrives among the stars.